Hi, welcome to ESP32 tutorial from Robojax. My name is Ahmad Shamshiri. In this tutorial, we're going to control 32 servo motors using this PCA9685 pulse width modulation controller module. I've connected two of these using Wi-Fi from web interface. As you can see, we have 32 servo buttons. Either you can control 32 servo altogether, stop them, or you can control only one servo, for example servo number 14, or any of the other servo that you want to control. You see they're rotating, so we can stop it. You can get the code for this project by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. So here I have two controllers. I want to solder these connectors. Because this has been already soldered, I can simply insert it here. And then once I solder it, I can bend it. Once I solder all these points, I can bend this. It has been soldered fully. I can simply bend this. And continue working with this now. And here this document from Adafruit website for their module, which we have exactly the same module except it's not branded, but the chip is exactly the same. For the first boot, we do not do any soldering. The address will be 0x40. And if you're using one board, you don't even mention the address. It will pick up automatically because that's the default address. But when you use a second board, we have to also tell the program that the first address is 40. And for the second board, we just solder first line, the A0. When you solder these 2 points, this becomes short circuit. And the A0 is short circuit. And we are assigning binary 1. And then 40 plus 1 would be 41, 0x41. This 0x means hexadecimal value of address 41. And if you solder analog 1, it will be 42 and so forth. Let me now talk about cascading or chain connection of these boards. I've soldered them here as I shown you. This is now complete. And now in order to make them work, if you want to connect 2, let's say, or even 3, 4, you can connect multiple of these up to 65 servo can be connected. So this is now 32, so you can connect 2 more here. It will be 64. Servos can be controlled. Because I2C communication needs address, this device by default has 0x40, or 40 is the address for this hex value, while these are not soldered. So if you solder this A0, then this will be 41. If you solder the other one, it will be 42. And plus this and this, it will be 42. If you solder first, second, and third, it will be 43. The address will change. So for that reason, I've soldered the last one. Now the address for this one is 0x41, or hexadecimal value of 41, and the address for this one is 40. And in this case, this is the servo 0, 1, 2, 3 up to servo 15 of board 1, and this is board 2, and this is servo 0, 1, 2, 3 up to 15. But in terms of count, you know that you arrange them such that this is 0, 1, 2, 3, that's 15, 16, 17, 18, and that's 31. So total 32 servos will be connected in this case. Let me now explain the wiring. I've explained how to wire all of these on the board. That is done. I'm just explaining how you can connect the external power and your ESP32. For the wiring of the servos and explanation of the boards, please watch video version 1. For explanation of how to connect these two boards together to control up to 32 servos, please watch video version 3. Two of these, but because the wiring have been soldered, because these have been connected via this jumper, you just need to connect to one of them. So I've connected the positive to this side and here, and then the negative on this side. And because this pin is called to V+, and the V+ is connected to this side, this pin and this pin are exactly the same. So when we have 5 volts here, this 5 volt doesn't go to the chip. The 5 volt goes only to the servos, to the middle pin, and this is also connected to this and to this pin. The chip needs 5 volts, so I will connect a wire from here, connecting it back. So here I'm connecting it. This pin has 5 volts from external power, and this 5 we want to connect it back here. So connect the jumper wire like this, and this will supply 5 volts to the chip here, to this chip, so it can operate. And now I have two. This is the ground. This wire is connected to the ground of ESP32, and then I have 2 wires which I'm going to connect. The second wire, leave it open. This is SCL, the third one, and the fourth one is SDA. I'm connecting these 2 wires. So now I have green and blue. Green is SDA, blue is SCL. SDA is connected to pin 21, and SCL, the blue, is connected to pin 22. If you're using this type of modules, they are labeled as G21 and G22. So G21 is this pin. This will go to SDA, and then we have RXTX and G22 here. 2 pin in between, so 21 and 22 are the I2C pins for this module. In order to start using ESP32 with Arduino IDE, you need to prepare Arduino IDE for that purpose. You will copy and paste it here. You see it says package ESP32 index.json at the end. So once you paste it here, click OK, click OK. This is telling Arduino IDE where to get the board driver. Click on Tools, and then Boards, Board Manager. And here, wait for this to complete at the bottom, this bar graph. And then type here ESP32. You see ESP32 by Espressif Systems. It says installed. In your case, it will not be installed. You will have install button here. Click on it, and it will take maybe a few seconds or a minute. And the installation, once is completed, click close. Now we have to tell Arduino IDE which board you're working with, because the driver is ready. Click on Tool, Boards. This is Arduino IDE which you will usually work, but scroll down until you see a line below that. All of these are ESP32, and ESP32 rover module is the one that you click and select, and the dot will appear. Now we have to select the port. For that, we have to find out which port we are using. Right click on the start menu, device manager, and you see port. Click on this arrow to collapse it, and mine is using COM port, Silicon Lab. If I disconnect it now, you will see that it will disappear. Connecting it back. So this is COM6. Note that. Click on Tool, Port, and you will see COM6 is already selected, and now you can write your program and run it. Let me now explain the code. The code starts with including wire.h, that is for ISP I2C communication. This is the Adafruit library, which I've taken it from this address at the top. I have the link. So I will give you a zip file that you click and download and save it in your computer, let's say my document or download. After that, click on sketch, include library, add .zip library, and then point it to where you have saved it. For example, if this was inside the download, go to download and select the file, the zip file, the library, and click open. After that, you have to make sure to close all the instances of this library, otherwise you will not be able to see it in the example. And here we are including the library using this header file, and after that we are creating two objects from this library, and we call it board 1 and board 2 because we have connected two boards. And we have to, because when there is two boards, we have to set the I2C address. The first one is by default 40 and the second one is 41. This is done the way that I have soldered it on the board, and the video version 3 is explaining that, how to do that. The link is available because the video will be very long. And here you will set number of servo, the maximum number of servo that you have, and it's very important. And here the servo minimum, servo maximum, or the experimented value that I found. You can learn about it from this video. The link is included. And then servo angle. This is a variable that is when the system moves the servo, the value will be stored here. Whatever you put, it will be replaced, so do not touch it. Servo step. This is a step when we move the servo from one angle to the other one. At the moment I have set it to move at the step of 10. For example, it goes with a 10, 20, 40, 60, and it jumps every time 10 steps. If you want to make it smoother, make it smaller, but it will take a little longer, so make sure to give enough time for the servo to move. And step delay, this is the delay between each move. So you have to play with this and find out whatever number works for you in terms of speed and performance. Servo angle minimum, servo angle maximum. These are the value that in case if you want to use all of them with one, but I have not used it here. I've created 3 arrays of 32 servo, so 8 is on one line, so you can see it easily, otherwise this would have been very long. This is the beginning and that's the end. And these are the minimum value for the servo. You can put any value here, but I've set them to 0 because the servo minimum would be 0, but you can put 20, 40, 50, 90, whatever, because if you want to make it a specific angle. And then we have also maximum, the same way I put them 180. This is servo 1, 2, 3, 4, 5 up to 8, and the same way up to 32. And this variable, this array is for servo maximum. For each servo you can set the maximum value, and in some applications you might not go up to 180, maybe less, so you can put that. But the condition is that servo minimum, these values must be smaller than servo maximum, otherwise this code will not work. And then all servo positions, these are the position of each servo when the code works, and also this is the initial position of servos. So at the beginning, wherever you want your servo to be, you can put them here. Once the board is booted, it will move to those angles. You can have individual angle for each servo. And then this is the servo number. Do not change it. At the moment I have just set it 100 because you will never have 100. Later on when the code runs, it will be replaced with actual numbers. Button pushed is a variable that is used. All servo, this is also used inside the code. This is a prototype for the function that I've created where it takes care of pushing the values on here. Once you click, it will be handled using this. And this angle to pulse is the PCA9685 requirement in a function which I have written these two at the bottom, and here we put them as prototype, so the code knows these functions are at the bottom. And here we are including this page. This is a page. When I click here, this is a page where you see that text size has been increased so much you cannot see it. Let me make it 29. So this is the HTML page. Actually this page, if I press Ctrl U, you will see the code. Now I'm pressing Ctrl plus to increase the size. This is the HTML page where it displays this page. So the text starts with HTML and ends with HTML, and the rest are just push buttons that are printing all those, and these are the style sheet. So the buttons are displayed, these buttons are displayed using these texts. And this file is creating that page for us. After that we have this wire.h, Wi-Fi.h, Wi-Fi client, web server, ESPM, DNS. These are all required for operation of Wi-Fi. And then you enter your SSID for your Wi-Fi, and this is the password. I'm just using this router for this tutorial. Once it's done, I will disconnect it. So I'm not worried if somebody knows this, because it will be always turned off. But pay attention, the R is capital. Whatever is your Wi-Fi SSID, make sure you enter it exactly the same way. Uppercase and lowercase matters here, otherwise it will not connect. And then web server is at port 80 initialized. This LED will turn on and off every time the server is running, so that's a good thing. I did not remove it. Handle root is where it handles the page. And these are the values. Header page 1, you see again these values are header page 1. These are the page that I have created. They are including it with the text. All of these will include, this for loop will create 32 push buttons, these push buttons, and this line is printing the page for us, or generating the page where you see it on the browser. And handle not found is when you type something unusual. For example, here if I type /book and enter, not found. So this is coming from here, or argument and then plain text. It will print it for us. So that is the job of this. It will tell you either get or post, and it will also show the method and arguments, whatever you enter. Inside the setup, from the board object that we have created, we have to use board 1.begin, board 2.begin. This initializes two boards, and also we have to set the pulse modulation frequency. 60 Hz is the experimental value that works. So these 4 lines must be there, and this is the initial value of the servos. If you don't want to run the servos at a certain position, just remove this, set those value otherwise. So I is going from 0 to maximum servo, which you set 32 at the top of the code. So I becomes 0, 1, 2, 3 up to 32, and then I become up to 31 because it starts with a 0. And then if the servo is less, if I is smaller than 16, which is 0 to 15, then it will control this board 1, because the 15 servo, first 15 servo is connected to board 1. And this I will come here, and then it angle pulse, all servo position. This takes the servo position with a value of I here you put. This goes and picks up the value from the array at the top, which I show you all of them are 0, 0, 0, and then it moves it to this location. It converts it, and this line moves the 1 servo to that location, and then I becomes 2, it goes to the next. When it is above 15, it goes to board 2. Here we subtract I minus 15, which means this program will always need between 0 to 15. And this is just initializing the serial monitor, so display the text for us, and that when it's printing. This is initializing the Wi-Fi, and this is, all of these are for Wi-Fi purpose, do not worry. And this line is the one that is handle root and then handle servo. This handle servo is a function that I've defined at the bottom, which will take care of the clicks. When the user types /servo, it goes to this function. So that's why when we do here /servo ? Move, let's say 1, and that's why this moves. It does something for us. The server begins with this line and it will print the text on the serial monitor. And then here inside the loop, server handle client. The job of this one is to continuously monitor and see if the user has entered something. And then this line, it says all servo. If all servo is true or equal 1, then this portion of the code will run and will control all the servos. And the delay stop is a value that you set at the top, how often after each servo you get the time. And then 100 milliseconds is here, and then if false, this is just a text for debugging purpose. If you want to display it, just type here true with lowercase true. At the moment it is false. And then if the push button, any of these are pushed, I call it push button. So you push these buttons, but not this one. And when any of these are pushed, and then the servo is above 0, servo number, and servo number is smaller than maximum, equal or above 0, and smaller than servo maximum, because somebody might enter, let's say 75. 75 is not a servo because we are using up to 32. So this will eliminate it. It will work only if you enter within the range. And then it will control first servo. If it is less than 15, above 15, it goes to the second board, and a specific servo will be pushed to the location where the user have sent it. And then after that, we have to set button push to equal 0, because button push is equal 1 when you touch this or click. So when the action is completed, we set it to 0, and the loop ends here. Now servo handle is this servo argument do equal all. If do is equal all, we say all servo equal 1. Else, if it is not all, we set it to 0. That's why the all servo test will not work. So the job of this one is, if I click right now, you see do equal all at the top. So this happens in here, and then here we get the servo argument move. Whatever is move is equal. If I touch this one, the first one, click on one of these, it says servo ? which is the main section, and then move equals 0. Now here that is a value, and we get that value converted to integer, and the value of this, whatever it is, because 0, 1, or 2, or let's say 9, this value is that 9, and will be stored in a servo number requested in here as an integer. Now then we will work with this to take action. This line again takes care of the boundary, make sure it is within 0 to 32 servo, and then button push is equal set to 1. And here this line checks if the initial value of the servo was minimum, then we set it to maximum. If it was minimum, we set it to maximum for the next time when you press it. So the servo returns this time, for example, when you press it, it goes to 0. Next time you press it, it goes to 180. So job of this one is to just switch that. Otherwise, minimum will be stored at the all positions, and here we set the servo numbers. Whatever is requested, it will be inside the servo number, where this line inside the loop will move the servo to that location, to that servo to the position. And then angle to pulse is in this line here. You will request a pulse width the whole thing, for example 250, that's a pulse width. So this pulse width is a result of calculation, experimental value that I said I've done it, but we have to convert it properly, because the angle, the value that you will enter will be between 0 to 180, but we want to convert it to a pulse that the board knows, which is between minimum and maximum. So the map will map 0 to servo minimum and 180 to servo maximum, and the other values are in between, and the result of this calculation will be stored in pulse and will be returned, where this line will be a value that sends the servo to that angle. So this was the code. To access it via browser, make sure the module is connected. After that, do not see anything on the serial monitor until you press the reset button on the ESP32. Once I press it, it shows that it can be accessed from 192.168.1.101, so we have to remember this. Or you can access it directly with this URL, Robojax ESP32, but in some network environment this might not work. So if it doesn't work, this always will work. So let's copy this and open the browser. Right now I have this URL open with the values ESP32, so I will just open it, just press enter, and it will open at 192.168.1 and then 101. I press enter in my browser. This is what I see. I can increase the size by pressing Ctrl and plus on the keyboard, so you can see it larger. And when I bring my mouse over on any of these buttons, here at the bottom, if you pay attention, it's very tiny at the status bar. It shows move equal 0, and here move equal 1, move equal 2, and the last one move equal 31. So it starts with 0 and it goes to 31. And when I press this, it moves the servo, but if you pay attention at the top, it says move equal 0. So here also I can type move equal 9, and now if the 9 was at the initial position or moved again, I can do it again, and now it moves. I can do move equal 0 back, so the first servo goes back and the last servo will return back. So this way, either you can type it there or here, but internally inside the code I have prevented this. For example, if you type 200, it will not work, it will be rejected if it is not within the minimum and maximum value. When I click on this all servo, this button is programmed, so all the servos will move between the minimum and maximum set inside the code. Whatever we have for each servo, we can set different minimum and maximum, and they will move between those values. And if I click stop, they all will stop. To tell you about the amount of current, all of this will consume 1.8 ampere when all of them are at movement. So you need a power supply, external power supply of 5 volts with 2 ampere minimum. But these are now, the current that I measured was without the load. So if you connect something to this so it can move it, then it needs much higher current. So make sure to have sufficient power supply when you're connecting devices. Or for example, I've connected here very metal geared servo. This is very powerful, and if you're connecting this, then you need much more higher power. So keep that, otherwise if the power is not enough, the system will shut down and restart, because when the current is increased, the voltage will drop and the system will shut down. So for that reason, you have to have enough power. This 14, if you pay attention here, it is from 0, so 13 is now 14. When I press it, once it goes to the minimum, next time it goes to the maximum where you set it. For all of these in the code, as I've just shown you, I've set minimum and maximum between 0 to 180, and you can change them accordingly. You see, when I click first, because the minimum is initially at the minimum and the servo is also at the minimum, it doesn't react. And also when I reboot, when I press this reset button here on the servo, I've set it so they all must go at reset position. Now you might hear some buzz. The reason for the buzz is that the amount of pulse width is out of the bound for that specific servo, because they are not universal, they are not the same type of servos. I have fine-tuned it with one type of servo, and later on when I run out of servo I purchase it, and unfortunately because of different manufacturing quality you will not see the same type. So if you're running some kind of application that needs multiple servos, make sure to buy them all at once from one manufacturer or one seller so you can get the same type and then calibrate it. For calibration of finding the pulse width, I have explained it in the version 1 of this video on my YouTube channel. The link is in the description as well. Now sometimes the servo will not respond, sometimes the ESP32 will not respond quickly. I don't know if this is the fault of my router or this is the response from the ESP32. In any case, so you can send any servo to any position you want. Let's see how we can control the servo motors using your mobile device. In order to control the servos, we have to be in the same Wi-Fi network. Let me just go and open it, go to the networks and Wi-Fi and select the same network that your ESP32 is connected, and it shows that I've been connected to Robojax. Let's go on the address bar and type 192.168.1 and the full address, and here is the screen. You can scroll up and down because the buttons are large. You can reduce the size in the style sheet if you want to make the buttons smaller. Now let me connect the power. Now let's see if we control all of them together and stop. You see they are rotating, so we can stop it. I'm in this corner where you can see only the last servos, so I have to scroll down. Thank you for watching a tutorial on ESP32. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. If you haven't subscribed to my channel, please do so now. Also, I'm going to show you how you can add a push button so you can turn on and off all the servo motors at once, like this. You can turn them on, or if you want to turn it off as well.